Hi everyone, this video is an exercise 11C question 2, and in this video I'm going to do parts C and D. So in part C we want to integrate cos 2x over cos squared x, and this section is about using trigonometric identities. So in this question we sort of have two options, but one of them is much better than the other one because we can either substitute use it because cos 2x is equivalent to 2 cos squared x minus 1. So we can either substitute that numerator and try to then simplify and solve, or we can also try to substitute cos squared x with half plus cos 2x. But the problem with the second option is that it's not going to be as straightforward as the first option. So let's just stick with substituting cos squared 2x and just writing the equivalent form of cos 2x. So yeah, it can be written as 2 cos squared x minus 1 over cos squared x. Now the advantage here is that we now have cos squared x in both denominator and numerator, so we can split the fraction and then simplify that. So we'll have 2 cos squared x over cos squared x minus 1 over cos squared x dx. Now 2 cos squared x over cos squared x is just 2, and then 1 over cos squared x is basically sec squared, so we get minus 2 sec squared x. And now this is a simple integration because 2 integrates to 2x, and then sec squared x is just a standard result, so it integrates to tan x. So we get minus tan x because it's minus sec squared x plus c. Okay. Now for part D, straight away we can just simplify this and write this as cot squared x dx, because cos x over sin x is cot x, but since they are both a squared here, so we'll get cot squared x. Now we need to use an identity here, and that identity basically says that 1 plus cot squared x is equal to cosec squared x. So if we rearrange the identity, so we essentially have 1 plus cot squared x is equal to cosec squared x. Now if we rearrange this and make cot squared x a subject, then we'll have cot squared x is equal to cosec squared minus 1, and that's exactly what we're going to substitute here. So that way we'll have cosec squared x minus 1 dx, and the whole point here is that cosec squared is just a standard result, so that's why I decided to make the substitution. So cosec squared x just integrates to minus cot x, again a standard result, and then minus 1 integrates to minus x.